IoT4 Industry webinar. I've noticed that we don't have many participants on at the moment, but I'm sure we'll get a few more people to join. We will be recording this event, so obviously the slides and the presenters' audio will be covered in that recording. As I said, my name is Tim Andrews. I'm the host for this presentation. I work for the MTC as a digital transformation advisor, and I'm a participant on the project team for the IoT4 Industry. You'll see on the screen in front of you the slides window, which is where the main deck of slides will appear. There's also a list of attendees, and we've also got the chat window. We have a couple of sections within the program where you'll get an opportunity to post questions, and if you post them in that chat window, I'll capture those and then pass them to the relevant person from the presentation team. We've also got a workbook which covers off a lot of the broad technology areas that we'll be covering in the presentation, and we'll be sending that out to everybody who registered for the webinar at the end of the event. There's myself onto the agenda. Apologies for that. So, as I said, the agenda is we've got 5 items on the agenda. The first item is about a 10-minute introduction to the IoT4 Industry project, to be presented by my colleague Eunice. We then have a short section for 20 minutes covering Industry 4.0 and IoT technologies, and this is part of the awareness training that comes together as part of this project. And then we've got two IoT technology companies presenting use cases, which will be an interesting. And it gives you some idea of the types of technologies that might be involved. We're then covering off some next steps in terms of participation in the project and a Q&A section. And as I said before, if you have any questions, please post them in the feed, and I'll take those out and pass those to the presenters. Now back on that. Take your apologies for that. Behind the scenes, we're all scrabbling around here trying to move between computers. So the broad objectives of the webinar today really are to provide some background on the IoT4 Industry project, to share some awareness information on the IoT technologies and some potential applications, and that includes some information from our third-party presenters, and also to understand the process for applying for this innovation funding and how you can get support on project proposal submission. So without any further ado, I'm going to pass now over to Eunice, who's going to cover off the first item on the agenda, which is the introduction to the project.
Hi everyone, it's Eunice Jakupovic here from the Manufacturing Technology Centre. So yeah, I'm the project lead from the UK perspective on this project. And what I'm going to do for you guys today is just go through the project, give you some information on the funding available and things like that. And as Tim has mentioned, feel free to just think about some questions, because we do have some availability where we'll take some questions and answer them. So the IoT4 Industry project is a 30-month project funded by Horizon 2020 programme of the European Commission. The project aims at accelerating collaboration between IoT solution providers, sensors, communication, big data, artificial intelligence and cybersecurity, etc., and manufacturers through matchmaking and funding opportunities. The project connects 3 information and communication technology clusters, having strong competencies in Internet of Things, IoT, clustered together, secured communicating solutions, SCS cluster, located in France, Microtech in Germany, DSP Valley in Belgium, and 4 industrial clusters having access to tool manufacturers and manufacturing SMEs, MESAP in Italy, Montblanc Industries in France, Paul Mecatech in Belgium, and the Manufacturing Technology Centre here in the United Kingdom. So before I get into the project, I'm just going to give you some information about the MTC for those of you who are not aware. So the MTC is part of the High Value Manufacturing Catapult umbrella, and we are one of the 7 centres across the UK. We are located in Coventry, and we also have offices in Liverpool. In total, across the catapults, we have over 2,000 staff, with MTC employing approximately 700 across both sites. And I guess the key takeaway here is that for every £1 of core government funding received, the net benefit to the UK economy is £15. The MTC was established in 2010 as an independent research and technology organisation with the objective of bridging the gap between academia and industry, which we often refer to as the Valley of Death. Our role has also increased to cover not only research and development, but also training, advanced manufacturing management, and factory design. We now have over 700 talented employees working with us to achieve our vision, and that's to inspire great British manufacturing. Our focus is to accelerate the UK's industrial growth, deliver innovation, change the way businesses compete, create and embed future skills, and maximise synergies within supply chains. So the IoT4 Industry project in a wider context. So what I'd like to highlight here is the project is focusing on 2 core stakeholders, if you like. So the first one is the technology vendor side, which is on the offer, and then the manufacturing side, so primarily SMEs who are in manufacturing, looking at their needs, and as well as promoting IoT amongst manufacturers and getting manufacturers to invest in IoT and start innovating. The project is also looking at training, hence this webinar which we are running today. So what we'd like to do is support manufacturers to deliver high-level awareness training so they can understand what IoT is, what are the benefits, how it can be used, and how they can actually apply IoT. And then we're doing this through support with our technology vendors, and we have 2 of them who will be presenting later on in the webinar. As well as the training, the core for the project is to create collaborative projects to support UK SMEs in applying for funding so they can do their own IoT projects. And that's the core for this project. And later on in the presentation, I'll go through the different funding sources available and how companies can get involved and tap into that funding. So when we began this project, we did some market research where we interviewed 21 clusters spread across 12 countries. So as you remember, we have several partners across Europe. And these interviews conducted covered over 4,000 members, and that was a mixture of manufacturers, IoT providers, and academia. And the reason we did this research is so it allows us to identify technology and application focus areas where IoT technology providers and SME manufacturers are likely to obtain the most benefit from collaboration. So hence why we've been doing this research, so we can understand the problems which manufacturers are going through, but then we can also understand the technology that's available out there to purchase, but also to do innovation with. So from that research, we were able to identify a few key areas or barriers to adoption, if you like. So lack of knowledge and skills with that, as well as lack of awareness, they came out as being on top. And what we found is a lot of manufacturers don't actually have the knowledge to implement IoT, but also truly understand its benefits, and they're not aware of this. And this doesn't just go for high-level management, because when we speak to manufacturers, we notice a lot of the times the directors or the founders or senior management, they understand what IoT can do, but it's the guys that are on the shop floor which are unaware of the benefits. And this is why also culture change is quite high to being a barrier to adoption. And this came across quite clear in our research. And again, we're hoping by doing this training, we're able to promote IoT, and we're able to kind of demystify what it actually is, what are the applications that it brings, and how manufacturers can actually start using IoT technologies to benefit them. Cost of investment also came up really high, and this is quite an obvious one. It is, most manufacturers think it's expensive to adopt IoT technologies. However, it isn't as high as we initially thought, and this is now due to a lot of manufacturers understanding that we need to be competitive, we need to start changing, we need to increase productivity, tap into new markets, and the way to do this is through new technology. And therefore the cost of investment isn't as big of an issue as it was before, as maybe lack of awareness is and culture changes right now. Too much legacy equipment. So it's been identified as a common problem that a lot of manufacturers think because they've got too much legacy equipment or old equipment, that it's too expensive or too time consuming for them to start adopting these technologies. Access to IoT, so this is down to there being a lot of technology providers out there, but at the moment it's knowing who to trust, who to go with. And again, it's why we're hoping that this project will broker really good collaboration and conversations between both the manufacturers who have the problems and also the IoT providers who have the solutions. So some key challenges we identified from this. I won't spend too much time and detail going through each one, but lack of competencies came out on top. So the cost of training, but then also there's the issue of talent leaving, which came out on top. Regulation, so a lot of manufacturers think it's safer not to actually change, and this can be due to cyber security threats, but also it slows processes in a fast-paced environment. So a lot of the times manufacturers are focusing on what they're doing, and they don't have time to start changing things. Unknown benefits, so the return on investment isn't defined, and it seems very vendor-led at the moment, and there's a lack of example solutions. Transparency, so a lot of IoT providers, who do you trust, and then the reluctance to change the mindset. So areas of focus, as well as identifying the challenges, the key application areas, or the key areas of focus from a technology point of view, were identified. Robotics and automation came out on top, so a lot of manufacturers are looking to implement automation and robotics, so replacing maybe dull jobs and repositioning people within the organization so they can automate certain processes. Sensors, so putting sensors on, retrofitting sensors on legacy equipment to start getting some data, to start using it for information to make decisions on the shop floor, really. So these were the common areas that we identified through our research. So what's in it for me? As I said, the core for this project is the voucher scheme which is available, the funding which is available for SMEs, and that's split into 3 different sections. So there's a feasibility study, which is up to 25,000 per SME, and this will target companies having an idea of an intended project, but it needs further analysing and technical support. So that's the feasibility study, and the maximum lump sum for this project for a feasibility study is €50,000. Then there's prototyping, so up to €45,000 available to do some prototyping, and that will target companies having already carried out a feasibility study and having the need to develop a prototype. And then finally, there's the demonstration / pilot, which is up to €60,000 available per SME, and this will target companies having already developed and tested a prototype with the need to demonstrate its efficiency on a larger scale. So this is the core funding available, and these are the 3 types of vouchers which are available in this first call. So just to give you an idea of the timelines, we'd like people to register their expressions of interest by the 20th of October so we can support in finding you partners, whether it be a manufacturer who's looking for an IoT provider or an IoT provider who might have a solution for a potential manufacturer. we'd like people to attend an IoT training awareness workshop. So this webinar, which we are running, counts as the awareness workshop. So we're trying to raise awareness for the project, but also IoT in general, and then build a collaborative project. That's the end goal for this, and then to apply for an innovation voucher. So the call for the vouchers has opened on the 20th of September, and it will close on the 20th of December. And then next year it will reopen again on the 10th of March up until the 10th of June. So the time is now to start collaborating and identifying potential areas for projects. So that will conclude the end of my section discussing the IoT4 Industry project. And I'm going to hand it back over to our host now, Tim.
Thanks, Yunus, for that introduction. As Yunus mentioned there, the calls are actually open now, and although the expression of interest closes on the 20th of October, it's not essential that you register for that expression of interest, so long as you are aware of the calls for the projects. I'm now going to hand over to Nandini, who's going to cover off the technology awareness. As I said, we will have time for questions later on in the webinar. So if you do have a question, either post it up in the chat session or make a note of it and post it up when we come to the open questions. So I'm just going to hand over now to Nandini.
Good afternoon, everybody. My name is Nandini Chakraborty, and I work within the MPC specifically on the digital manufacturing side of things. So I will talk about Industry 4, smart manufacturing and IoT over the next 15 to 20 minutes. And I would start by saying that Industry 4.0 and smart manufacturing IoT, this is a paradigm by itself. So I'm going to have a literally whistle-stop tour to talk you through what is Industry 4, what is smart manufacturing, what does it actually mean for us, why are we doing it now, what are the technologies that are involved, and what can be some of the use cases or applications of applying some of these technologies. And in terms of the industrial revolution, so there has been 4 industrial revolutions so far. So the first industrial revolution is the Industry 1.0, which is basically the mechanization, steam and water power. The second industrial revolution was coined as Industry 4.0, which is the mass production and electricity. The third one is all about electronics, IT systems, automation. And the fourth industrial revolution, that's Industry 4.0, it's all about cyber-physical systems, and this is where we are. The lines between the physical and the digital technologies are getting more blurred than ever before, and the speed of technological breakthroughs which drive it are unprecedented at the moment. So I think the logical question is, why are we doing it now? And why is the fourth industrial revolution happening now? And what is it different now at this moment, and critically, why is it important to understand it, and how might UMI affect it? There are several key factors driving it, so I will be talking through 4 of them. The first one is globalization, means that we are now more than ever having to compete on a much global scale. We have to be cheaper and faster to stay ahead. The second one is dynamic value networks. What it means is everything is happening quicker. The supply chain and the technology is more dynamic than ever. Businesses need to be able to change in a much more effective manner and to respond to the industry demands in a much more effective and efficient way. The third key factor is jobs and more empowered jobs. People do expect to have better jobs now. They want to be more empowered and to feel that they are adding value or to feel rewarded. The third factor, or the fourth factor, is the untapped potential in data. So in terms of smart manufacturing, in terms of IoT, there are lots of data being generated. So manufacturing in particular generates a lot of data. So how do you use this data to actually get more actionable recommendations or actionable insights from the data? So The next slide is about Internet of Things and what does it actually mean. So these days all of us use smartphones, we have smart TVs at our home, we've got smart watches, smart meters, and even some fridges are termed smart fridges as well, smart washing machine as well. So what does all these devices have in common? It is connectivity, internet connectivity. So all these devices to a certain extent are connected to the internet. So the connectivity of smart devices are often done wirelessly and over an internet or over the network, and this paradigm is termed as the Internet of Things, or IoT. The Internet of Things will be a major contribution to Industry 4.0, and this bit is commonly referred as the Industrial Internet of Things, or IIoT. Industrial Internet of Things actually provides the framework for industrial connectivity. So how do we connect the machines? How do we connect the robots? How are factories connected? How can the supply chain be connected, etc.? And all these values can actually provide valuable efficiencies to the overall manufacturing. So how is Industrial Internet of Things different from Industry 4.0? The terms IoT, Industry 4.0, Industrial Internet of Things are commonly used interchangeably and often used to describe the same thing, although there are some subtle differences between them. Industry 4.0, as we have already heard, looks at a range of different technologies or technology enablers which are brought together, and these technologies as a combination can help to transfer manufacturing technologies. IoT technologies form a big part of these technology enablers, in addition to other technologies that we keep hearing commonly: additive manufacturing, 3D printing, artificial intelligence, augmented, virtual reality, cybersecurity, etc. Sorry, having a bit of technical problems. Right, back on. So in terms of what are these technology enablers that I hinted at in my last slide. So there are lots of sensors, sensory devices, instrumentation devices, communication technologies, wireless, wired, cybersecurity. So with this current internet era, so there is a lot of data being captured. Ensuring that we can capture this data in a trusted manner is a key. Artificial intelligence, what it means is actually allowing the machines to actually analyze the data independently and take some autonomous decisions by themselves. Big data and analytics, again, with the volume of data being collected, how do you actually analyze these data to get some insight? Simulation and modeling, how to simulate the virtual physical world, how do you represent the physical world in a virtual environment. Cloud platforms, we keep hearing about different vendors, people like IBM, they have some sort of cloud platforms. Microsoft have a cloud platforms as well. There are a number of different technology vendors now offering cloud platforms. So what does it actually mean? Robotics and automation. So automation has been there for quite some time, but I think manufacturing such has been quite slow to accepting it. So all these technologies add a big benefit to manufacturing as such. So the next few slides, I will actually dig a little bit deeper into the individual technology enablers. The first one are the sensors. The sensors play a pivotal role in any IoT solutions. The sensors are the devices that provide the raw data that is sent, stored, and analyzed. Sensors can be actually inbuilt in any industrial device, machines, or they can be retrofitted as well to old legacy machines as well. There are sensors for all sorts of data capture, for example, temperature, vibration, imaging, location, etc. The fundamental components of automation of any other systems are the sensors. So the sensors are, in a way, the eyes, ears, and fingers of any system. If the concept of industrial IoT are to succeed, we need more effective, powerful sensors. The leaders in the industrial Internet of Things race may be very well innovators in the development of new sensors, and these sensors are just not technologies, but there will be concepts of energy harvesting and battery management as well. So I'll just manage to go to the next slide. So the next technology enabler is the communication technologies. So an industrial internet gateway, as seen in this slide, is a physical device or a software program that serves as a connection between the different field devices, and these devices can be sensors, actuators, smart devices, which can be hosted or mounted on any machine or any piece of critical equipment. And it acts as a connection point between the cloud platform and the controllers. So to send data from an IoT gateway to the cloud, a communication protocol is used, and there are a variety of communication protocols that can be used. So all these protocols offer a different sort of value to the developers. Advantages of specific communication protocols can include range, security, power usage, and battery life. So the next hot topic, I would say, is cybersecurity. So in the current era, which is very appropriately termed the digital era, data can be considered as a currency, and as more information and instructions are digitally shared across many platforms between several locations, the risk of unauthorized parties accessing this information is becoming of increasing concern. Digital communication of the industrial Internet of Things use cloud, Internet of Mobile networks, brings many benefits to manufacturing, but also brings in increased security threats. Older equipment, which may have no built-in sensors or no built-in security aspects in mind, there may be gaps in the IT architecture of a particular organization as well. There can be undefined processes and procedures with a failure to conduct appropriate risk assessment, and all these individual elements can add to the security vulnerability as such. The next topic is big data and analytics. So the manufacturing industry creates more data than any other sector at the moment. Big data by itself refers to a very big, large and complex data set which can grow very rapidly due to the fact that the data is often collected from numerous locations, numerous smartphones, smart devices, RFID readers, to software logs, as well as different components within the manufacturing shop floor. Big data is often characterized by 4 V's. So the first V is the volume, that is the amount of data that is collected. The second V is the variety, so this is the number of different sensors can produce data in different formats. Velocity, often the velocity and the speed of the data is very, very fast. Sometimes it can be real time as well. And the fourth V is the veracity, which actually means the quality of the data. So having data in a lot of quantity is not good enough to get any actionable insights. It's the quality of the data which is key. So advanced analytical techniques like artificial intelligence as well as machine learning can provide valuable insights from the data. In terms of one of the most promising applications of big data analytics is predictive maintenance. The last technology enablers that I'm going to talk about is the cloud-based platforms. So cloud-based platforms aim to make certain tasks much easier, and some of them are managing the IoT connectivity. Carrying out analytics, you can do cloud-based analytics as well. Cloud platforms can help us in monitoring and visualizing real-time data insights. Cloud platforms can also be used for building business applications. In terms of application areas, so the top 5 expected application areas of industrial IoT is predictive maintenance, which means the ability to predict the maintenance of industrial equipment more efficiently. Instead of being reactive, you become more proactive. The second area is logistic and supply chain, so having a connected supply chain gives us the visibility. track and trace, so the ability to trace components within the shop floor, monitoring of applications and process analysis, and this can be, for example, predicting the quality of a part or of a product in real time or predicting it in advance. And the 5 core relevant topics of industry IoT projects can be smart data projects, smart sensing platforms, connected systems, energy management systems, and robotics and cobotics, which is having collaborative environment where robots can work in a safe environment with human operators. So I am going to pass it on to our host, Tim.
Thank you, Nandini. That's given us a good overview of the technologies and the areas in which they play. And we're now going to move on to the section where we invite a couple of our IoT vendors, and they are covering areas that are very topical in terms of the technologies that Nandini mentioned, which is Brainboxes, who cover off the connectivity and sensors piece, and Sensei, who are a cloud-based predictive maintenance company. Just before we do that, we've got a couple of minutes for some questions. We have a question that was posted whilst the presentation was going on, and that's regarding the registration for expression of interest, and that's being done via the IoT4 Industry website. So we'll post that in the chat feed now, and on that there's a Innovation Vouchers tab, and there are 2 buttons on that tab. One is for posting your collaboration project, and the other one further down the page is for posting your expression of interest. So that's the route into the IoT4 Industry project. And Eunice is just posting that on the feed now. What will happen is you will be rerouted to go to a funding box site, which is set up directly for this project, and that allows us to structure the data input and ask the relevant questions, but it is all part of that process. So unless we have any further questions, I'm going to now hand over to Stephen from Brainboxes, who will cover off their technology and how it can contribute to the IoT4 Industry technology area.
Thanks, Tim. I promised that I'd keep this to 5 minutes, so just start my stopwatch now. So I'm Stephen Greer from Brainboxes. We've been around for 34 years. We've been in the business of connecting things to other things. Previously, last 20 years, we were connecting things to computers, but more recently, been connecting things to the network and things to the Internet of Things. Hey presto! So we've been doing this for 30 years. It's our view of IoT and Industry 4 is that there's an increasing demand for efficiencies, and web technologies are a way to present that data and tease out trends. There we go. So some of the issues that customers are solving. So it's all well having the technology, but you have to have a problem first. And it's interesting that the problems that people have, and they're using either clipboards or proprietary systems to solve, is things like how many units have we made, or how long has the machine been running, or I need to know when something's gone wrong. And those are the types of things that we've been helping customers using our products, our modules of products that we make that connect devices and sensors and allow you to connect and access that data on the network or or via the internet, if that's the way you want to go. Our view is that the Internet of Things is not just about connecting devices to the internet, it's about putting the internet on those devices or on those machines. You don't have to send your data up to a cloud for it to be internet enabled. A web browser is a very good way of seeing what's going on the factory floor, and that can just be either a big screen at the end of the factory, or a phone in the hand of your operations manager when he's sat at home in his armchair and being able to see what's going on in the factory on the night shift. This picture, a little bit like Nandini's, but maybe not so pretty, but our boxes can be retrofitted to existing machinery. So if you've got some equipment, you can add one of our, I hate to use the word gateway, but it's a good catch-all term, but wiring in a couple of sensors that may already be installed in your factory on the machine, or maybe adding a couple of low-cost photo eye sensors. Once that's on the network, you can then send that to something like IBM Watson, which is their cloud platform, which gives you insights and intelligence and looks for hidden trends in the data. And then that can be sent back down to the dashboard, either on a big screen or on a mobile device. So it kind of mirrors what Nandini mentioned a few moments ago. Our view of data capture, we see that there's 5 levels to that. So in a typical factory floor, you've got lots of sensors hidden away in a machine. So that can be a green light flashing to say the machine's running. If you've got an electrical engineer, he can then make sense of those signals. So when the fan and the green light is on, that means the machine's running. And when it's not, it's off. So if you can log that data, you can start to make statistics out of it to say how long the machine's been running for, how many you've made, how long it takes to make one unit, or your overall equipment effectiveness. Once you've got statistics, you can start to make insights. So one shift is more productive than the other. We get more breakdowns at a particular time of year. And then the sort of final stage is making the machine tell you, so the predictive maintenance. When is my machine going to break down? Or it emails you to say, there's a problem here, you need to order some spare parts. So what part, a couple of examples. We've got a customer that makes food waste disposal system. They had their own control system built into the machine. So you pour food waste into the top, it chews it all up with enzymes and allows it to be poured down the drain. This is a great system, but they weren't able to access that data. So our module was added on to the control system, which was able to then detect how many times the door was opened, how much water went in, how much went out, and that was sent up to in this case, it was a cloud application, and that gave them an instant dashboard of how much money had been saved, how much CO2, how well the machine was being used. Quickly go back. Another logistics warehouse. So lots of these boxes going around the warehouse, and every now and again, if these boxes were poorly placed, you see them shooting in on the side. If they had too many of these boxes in the wrong place, they would crash and have downtime. Downtime's not an option when you've got to get 20,000 orders out of the system. So we were just using 4 signals from some photo eyes and presenting, sorry, I've gone backwards, a dashboard. And they were able to, the maintenance, the operations manager was able to negotiate some downtime. So you see the thick blue line there. That was it. He was able to say to the night shift, look, you're not as busy as in the day shift. Let's have an hour of downtime during the quiet period to prevent any downtime during the busy periods. this system, we were just tapping into some red LED lights. So when the cranes that they use to pick the orders, if we could tell them how long that red light was on for during the day and how many times, he was able to get an instant dashboard view of how much downtime they'd had with the cranes. That was currently being done with a clipboard and a piece of paper. And anecdotal data. This was hard evidence for him. The Brainboxes have a range of modules that allow you to extract those signals and turn them into machine states. By the end of this year, we're going to have a device that's got some intelligence on board. So you can start running applications on it to give you the statistics. And we work with a range of software partners that would then give you the intelligence and the insights. That's a brief overview of Brainboxes, and we're here to help you. If you think you can collaborate with us, if you make sensors, or you've got a problem that you're looking to solve, look for an easy win. Look for the biggest problem, and let's see if we can help you. Thanks very much.
Thank you, Stephen. That's a really good insight into some of the technologies that we've been talking about earlier and how they can be used to visualize what's happening in your plant. I'm now going to hand over to Lars from Senseye, who's going to talk about cloud-based predictive maintenance and a bit of AI in there as well.
Thanks very much, Tim. I hope you can all hear me very well. So I'm Lars. I work for Senseye, and Senseye's strapline is scalable predictive maintenance with automated condition monitoring. It's a bit of an unfortunate title because predictive maintenance is, in my opinion, a very used and abused word. In reality, just to dwell on that term for a second, it's to deliver predictive maintenance. First of all, hardly anyone's doing that out in the industry. No one's really actually achieving true predictive maintenance. But it's definitely not achieved through predictive analytics. There's a very big distinction I make between IT activities and what is basically a mechanical engineering exercise. So when companies talk about predictive maintenance, what they really should be all talking about is condition monitoring. And this is really looking at the data that comes out of sensors. Such as from companies such as Brainbox and some of the companies mentioned previously. Can we move on to the next slide? Yeah, thank you very much. So the reason Senseye is in business is because downtime has a lot of focus. There's some quite shocking statistics really. Basically a quarter of manufacturing cost is attributed to downtime. And when there is a downtime or maintenance activity, it's often over 90% of the time is a crisis activity, and that's really shocking. In the automotive sector, these are, like I said, McKinsey statistics. They're a few years old now. It's actually closer to 4 million pounds worth of dollars worth of the cost of the downtime per hour. This varies in other sectors. I can tell you in the paper and pulp industry, it's £50,000 per hour. So the numbers are quite significant. It's often why companies have a lot of focus on trying to achieve this holy grail of predictive maintenance. Can we move on to the next slide? So what Senseye actually delivers is not a platform. It is an application. It's a ready-to-go application that takes the chief data, so the condition indicators. So that's voltage, current, temperature, torque. These types of measures that are in equipment without putting retrofitted technology on there, and starts to run an analysis looking at firstly what the steady state is of that machine, and then starts to look for trends in the behavior. But where it's very different to predictive analytics, because that's very much a statistical exercise, is that actually since I add a layer of context to those insights. So if the machine's drawing more, if the motor's drawing more current, and at the same time the temperature's going up, So that could be typical of a bearing breaking down. So you could start to look at, potential failure modes, and this is what Senseye delivers through an application that you see here, a web-based application, and through an API that then you can push these insight from the behaviors of your assets into your operational enterprise layer applications, that's your Tableaus, your IBMs, and so forth. Also the insights are actually delivered through emails and text messages. There are various notification methods available. If we move on to the last slide. So moving away from just what the industry tells us, these are some of the statistics or some of our, so after having deployed successfully the technology within our clients, we obviously monitor that process as we go along, and we've shown to reduce downtime at the largest car manufacturer in the UK currently by 50%, and lowering maintenance costs and increasing basically maintainer productivity and being able to schedule and prioritize maintenance tasks more effectively, and ultimately increasing the downtime accuracy forecasting as well. That is Senseye in a nutshell. More than happy to answer questions as and when.
Okay, thanks for that, Lars. That's a very concise coverage of a complicated topic. But as you say, I know that the platform takes a lot of the complexity out of the decision making through the clever algorithms you've got behind the scenes. So I suspect there will be a number of questions on that, and we'll definitely provide contact details as part of the follow-up to this webinar. I'm just going to hand over now to Eunice to cover off the next steps within the IoT4 Industry project, and then we'll have a Q&A session. So if you can think up your questions as we cover this off and post them in the chat, we'll sit here ready with the team to answer that. And that's either questions for the IoT4 Industry team here at the MTC, or technology-based questions to Nandini, or indeed questions to our two presenters from Brainboxes and Senseye. So I'll just hand over now to Eunice, and he's just going to cover off the next steps.
Hi everyone, it's Eunice here again. Thank you, Tim. So yeah, I hope now after everyone's heard a little bit more about the IoT4 Industry project and IoT in general and the different technologies, and also had a chance to look at some potential case studies, that we have more of an understanding of what's going on. So I would like to just talk about the next steps for the IoT4 Industry project. So the first call for the expressions of interest open on the 20th of September. Sorry, not expressions of interest. Call for vouchers open on the 20th of September. And then this will be open till the 20th of December. And that's when the deadline for the first call will be. So from this stage, what we would like to do is encourage as many manufacturers to sign up their expressions of interest, and also IoT providers to register their expressions of interest, so we know that you need support in finding a partner. So this is whether you're a manufacturer who has a problem and would like someone to help you with a solution, or if you're a solution provider and you would just like to raise awareness of your product or service that you can offer in terms of IoT. So our job here in the UK as facilitators of this project is we want as many UK projects to go through, as many of them as possible to be accepted. So we are here to support UK companies, and we will be sharing a lot of this information and sharing contact details, and you can get in touch with us to find out exactly how you can fill in the application and just get some almost sense check. Is your idea viable? And it's not guaranteed that you will get accepted, but we can kind of steer you in the right direction. And the first call, it's 20th of December, it's ending, so the time to start thinking about this and approaching companies and approaching ourselves is now. Once we close the applications on the 21st of December till the 14th of January, we're going to spend some time just going through the different proposals and just doing administrative checks on them. And then from the 15th of January, for about a month, we'll have an expert panel who will review the proposals. And as I've said, we've got partners from all over Europe, so any UK proposals won't be assessed by any experts from the UK, and we'll have no kind of control. The MTC won't have any control over the proposals. Following that, there'll be an evaluation and summary reports, which will be sent to everyone. And then grant agreements hopefully will be signed from the 22nd of February to the 1st of March, and then the projects can be executed. And the timescales for projects was on the previous slide I presented. So, for example, the feasibility study has to be executed within 6 months. The details of all of those can be found on the website, which we will share. Yeah, so that's everything, and they're the important dates that you need to remember. And as I said, all the information is on the link which I've posted down in the chat box, and we're happy to answer any inquiries that we have following this webinar, but also right now as well.
Thanks, Yunus. As Yunus mentioned, if you could post any questions you have regarding the project or to our other presenters, if you could put that in the chat now. We've been collecting questions as the project sort of built momentum, so we do have a sort of a few of those that we could share with you. One of which really is what constitutes an SME, because as you know, the project requires a collaboration between a technology provider and an industrial SME, and so the definition is it's by the EU reckoning, which is a company with a turnover of less than 50 million euros or less than 250 headcount. There is also one of the key parts of this project is to encourage collaboration across the EU, and there's a requirement that the two collaborative parties must be in different regions, and these are the EU NUTS regions, as they're known, NUTS 1 regions, I think, and it's important that the two collaborative parties are in different regions. Now, what that means in the UK is that there are about 6 NUTS regions in the UK. So you can have one party in Scotland and one party in the northwest of England, or one in the northwest and one in the northeast. What you can't do, or what will fail validation, if you like, as part of the evaluation, is for 2 to be in exactly the same area. So that's something to bear in mind when you're working with an SME on putting together a proposal. Yunus touched on it quite briefly, but one of the questions that's come there is how are the projects evaluated? And as you mentioned, there's a team of independent experts that have been appointed by each of the project partners. There are 7 project partners, and each appoints several experts who don't work for those project partners, so they are independent. Some are from academia and some are from industry, but they all have extensive CVs in manufacturing technology, and each proposal is assessed by two experts, and those experts are from different project partners. So it's trying to make sure that it's a very clear and unbiased approach to project evaluation. One of the other questions this raises: how does the funding come about once the project proposal has been accepted? Once it's met the criteria and we get the grant agreement side, the SME will receive 20% of the funding at the start of the project to get the project rolling. The remaining 80% is paid at the end of the project, provided all of the agreed measurement criteria are in place. So I hope that gives you some insight into the elements of the program. We've already posted on the site the link to the industry website, and there's quite a lot of information on that site with the links that will take you through to apply for expression of interest, and also for the the project proposals. If you want to contact the MTC directly as the UK project partner to ask any questions you have or to clarify any points regarding the process, then I've posted the email address directly on the slide in front of you. But I'm just going to hand over to Eunice, who will talk a little bit about how the MTC can support potential partners.
Yes, so what we would like to do is have anyone who's interested in the project first just let us know. And as I said, this is both manufacturers and also IoT providers. If you are an IoT provider, then we'd obviously like to know exactly what it is that you provide and you know, the type of problems that your solution can solve. This will help us when we're looking at the type of manufacturers who are requesting support as well. So we'll be able to identify potential matches and do matchmaking from that side, the same way that we would with the manufacturer. So we would like you to, you know, email us and arrange a call so we can understand exactly what kind of problem you're having or what project idea do you have as well. And the same way we would try and identify specific partners for you, or we'll already have in mind IoT providers which can support you. Now that's our role in doing this matchmaking, but at the same time, if you already have so if you're a manufacturer and you already have an IoT provider which you want to work with, you can do a joint call or send us an email and say, you know, I'm a manufacturer, this is my problem, I have this potential supplier, can we work together, is there scope for us to do something together? And again, we will have a look at that and we will try and understand exactly what kind of project that you're trying to develop and steer you in the right direction. So that's the partnership side. The other side is the application process. So the application process is live now, and what we would do is encourage you to visit the website and have a look at the different criteria and the application form itself. And Tim can correct me if I'm wrong, but it's 10 pages roughly, the actual application form. We'd stress you to have a look at that form and try and digest it and see if you can do almost a version 1 draft. And we don't mind if you send us these drafts and we can just have a look at them and give you some comments and offer you feedback on how to strengthen these proposals. But we do want to stress we won't be writing any proposals for anybody, just steering you in the right direction, and support from us doesn't guarantee that your proposal will go through. It's all about strengthening it and making sure you have the best possible chance of being accepted. From the MTC's point of view, we just want as many UK projects to go through, so we have no financial benefit for any project that goes through, but also gets accepted as well. So for us, it's just about supporting UK manufacturers and making sure that we're really well represented.
Thanks, Eunice. Just one other final point I want to make before we end the webinar is that we have a role as a project partner to help find collaborative partners within the projects. So if you're a manufacturing SME and you're looking for an IoT provider, if you contact us, we will look to find a potential technology provider or within the broad group of clusters that make up the IoT4 Industry project. So we've got partners in France, Belgium, Germany, and Italy. And so if you're looking for a technology provider, or if you're a technology provider and you're interested to find an industrial SME who might need your services, again, our role is to put these groups together to be able to create collaborative projects as part of this program. Okay, so I've got a final question. The IoT provider doesn't need to be an SME. So the question that's been asked is, should the IoT provider be an SME? And that isn't the case. The important thing is there is an SME in the project, and the SME receives the funding. So the vendor IoT provider can be larger than SME. Right, if we have no further questions, I'm going to bring the webinar to a close. I just want to thank our presenters and obviously our attendees for taking the time to join. I hope you learned enough about the project to move forward and maybe participate. If you have any questions, please post them to the email address that's on the slide there. As I mentioned to you, the webinar has been recorded, and we will share that with participants and anyone who registered but didn't join the webinar. We'll also be sending out a workbook and a feedback form, which I hope you will return to us to give us some information on how you thought we performed today. So without any further ado, I will close the webinar. So thank you very much for your time.